two different apple types are going to be your X. Okay, this video here is going to walk you through target number 53, which is the homework section of the target. And what I need to have you do first of all is read through the question and try to set up and define what your X variable is and what your Y variable is. So pause the video right now, read the problem, and set up what X and Y are. Criteria have already been laid out for you what need to be made for the inequalities. So when you talk about maximum acres, you have to read the problem carefully. It starts out right in the beginning that the farmer has 10 acres to plant. If the farmer has 10 acres to plant, that means he cannot plant more than that. So just think for a second, pause the video, and think about what that first 10. So basically what it's saying is you're maxing out at 10. You can plant less than 10 or equal to 10, but you cannot go over. That's what the less than symbol is all about. Now the second one, you'll notice that there's a minimum also defined in this problem. He says that he has to plant at least 7 acres. That means he cannot plant 5 acres or it costs. Read the problem where it talks about the cost of a Braeburn and the cost of an acre of Honeycrisp and see what that total needs to be. No more than in the problem. That's 200x plus the cost it takes to plant each Braeburn. That would be 100y, and that total cost cannot exceed $1,200. He doesn't have more than $1,200 to spend, so you need to put $1,200 right here. Okay. Next, our bottom criteria then, it says the time available. There's only so much time to plant this that's given in the problem. And it says he only has a total of 12 hours to plant, and it takes 1 hour for a Honeycrisp and 2 hours to plant Braeburns. So, pause the video what you think the equation should be, or the 12 acres, or 12 hours in the problem. Now, also before you graph this, we want to think about what the profit equation is going to be. Your profit equation, read the problem and write down what you think the profit equation is. Pause the video, take a second to think through the story. You'll notice that Honeycrisps are a lot more expensive than Braeburn apples. So what you'll notice then is that if I'm making the equation, each Honeycrisp is $500, so that means you're going to go 500 times X plus the profit you're going to make on the acre of the Braeburn, which will be $300 for every Y or acre of Y that you plant. All right. So now let's do the next step, which would be to graph it. The first thing you should do before graphing is define what your axes are going to be. Your x-axis will be your Honeycrisp, and your y-axis will be your Braeburn. Now, the trick to graphing these when they're in these equations of these lines, when they're in standard form, is to graph them by the intercepts. Remember, when you graph an equation by its intercepts, to find an intercept in general, you have to put 0 in for the opposite letter. And when you basically put 0 in for the opposite letter, you're making an equation that's easy to solve in this case, because when you put 0 in for y here to find the x-intercept, you're simply looking at an equation that would then say x equals 10. So what that means then was when you're graphing this first equation, you're going to have an x-intercept of 10. So count out on your x-axis, put at least 12 hash marks across the bottom and at least 12 hash marks up the side if you're setting up your axes. So right now, try to see if you can graph the first equation by putting 0 for y, like I just did here. I'm covering it up as it goes away. Then I have an x-intercept of 10. So 1, and you'll put a dot. Next, once you have your 2 dots, try to find a straight edge. I'm going to use a folded piece of paper here, and connect the 2 dots that you have. Okay? Graph. And this graph that I just drew here is your maximum acres. So it's easier for you to go back to if you need to. And then if I connect those 2 dots with your straight edge, I find folding a piece of paper in half creates a pretty nice edge that your pencil will stay on. And you get that graph as well. What this equation says now, or the graph is telling you, is that if I have a maximum acres of this top part here, and the bottom part here is your minimum, my graph is perfect, so here, that's my minimum acres, then I need to write 2 more equations that are going to be on the graph, or graph 2 more equations that are going to then define your possibilities for cost. Now, if the first one is less than 10, you're shading on this side of this diagonal line. If the other one says you're going minimum at 7 acres, that means you're going above this. So what we're basically saying then is between these 2 lines then are the possible areas that you're going to be planting. You cannot plant down here. You cannot plant 4 acres of Honeycrisp and 4 acres of Braeburn. It's not possible. It doesn't fit in our criteria. The total has to be at least 7. Now I kind of screwed that up because 4 is actually on the sheet here. But if I did 2 acres of Honeycrisp and 2 acres of Rayburn, that does not fit our criteria of the minimum amount that we want to have planted. Okay? So now let's do the next part. Graph the planting cost. The planting cost is this, so you got to figure out what is the y-intercept or the x-intercept first. So if you put 0 in for y, or simply cover up the y term, you have 200x equals 1200. If you divide both sides by 200, then you'll have x equals 6. So in other words, your x-intercept is going to be 6 on the planting cost. Wouldn't hurt to label it. And then your y-intercept will be 12. You put 0 in for x here and cover up. Okay. And then the next thing is, we have one more. This line that I just drew here is talking about the planting cost. Okay. Last of all, we're gonna graph the time available by its intercepts. The time available for the x-axis is going to be 12. You put 0 in for y, you cover up this, and you get x equals 12. So your y-intercept is at 12. And then the other one, if you put your finger over this one, because you're going to put 0 in for x, gives you 2y is less than or equal to 12, which in this case, when you divide both sides by 2, your y-intercept will be at 6. So then, we're going to take those two dots from the straight edge, graph paper. This is a much smaller scaled down version of it, but I'd like you to make sure you're using quality graph paper, because when you do this, the crossing places that these lines will be at are going to be nice round numbers. Now, understand that my graph is not perfect. Okay, neither should yours be if you're doing it on the target sheets. Now think about it for a second. We're going to be shading above the minimum, below the cost, and below the max. This last one we just did was below the time. This one right here is your time. Okay. Now, if you're going below, it's kind of hard to see. I'm going to zoom this in so you can see it closer then. In this first graph then, if you're going below each of them, you're going to be looking at where these lines cross. So there's one that's going to cross right here. There's also a graph that's going to cross, it should have crossed somewhere around here. And if you're going for where all these shaded regions overlap, it's going to be where this little triangle is that you see here. If you're going below both the two diagonal lines, the cost and the time available, then this graph will also then be above the minimum amount, which is this diagonal line that you see right here. That's your minimum cost. So therefore, that little triangle that you see there is your possible combinations that you can then plant. There are 3 vertices on there. One vertice is a vertice that's going to be at 2, 5. This vertice right here is at 5, 2. This vertice right here is at 4, 4. Now that you have your vertices labeled, we need to then think about our profit. Our profit, it said, was the profit was 300 for every Brayburn and 500 for every Honeycrisp. And in this combination, then, if you take 2 times 500, you're going to get 1,000. 3 times 300 or 5 times 300 will give you 1,500. Add those together, and you're going to get $2,500 for this first one. So think about what the cost is then, or the profit. I mean, when you figure out the different combinations, you're going to get $2,500 for this one. This one right here, if you put 4 in for x and 4 in for y, you're going to get a total of $32,000 or $3,200, $3,200. And this last one, if you put 5 in for x and 5 and then 2 in for y, you're going to get $3,100. So there is a best possible scenario in this case. It's always best that you test out all the coordinates and the vertices in the profit equation. It's not going to always be the perfect place where they cross here, where you're maximizing the amount of time and planting cost. In some cases, you might make more money here and here. But in this case, yes, it did work out for 4, 4. That is your best combination. So to finish off this problem, what the farmer should do is he should plant 4 acres of Honeycrisp and 4 acres of Rayburn to make the most amount of money. Hopefully this video helps you understand how to do the target for number 53, and hopefully then see the process of how we're going to do this in the future for other target 53 type questions.